in this lecture, I'm going to cover three important things of SR flip-flop. These are truth table, then excitation table, and characteristics equation. Characteristic equation. These three things I'm going to cover in this lecture. Now, let me start from the truth table portion of SR flip-flop. So what we have seen in the last lecture, SR flip-flop truth table can be given as this way. So it will have S input, R input, and present state, that is Qn. And using these three things, you need to find out Qn plus 1. And every time you need to consider clock. Okay. So make the three variable combination 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 0, sorry, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. Okay. Now, 0, 0 combination of SR is known as unchanged, okay, or no changed state. Okay. So in order to understand that, you can go through the previous lecture of SR flip-flop. Okay. So no change means if the present state is 0, next state will also be 0. As this particular thing is known as, let me write the clock also. This is the symbol of clock. Now this first two thing, the 0, 0 combination is known as no change. This particular combination, S equal to 0, R equal to 0. This is known as no change. Let me write here. Okay, what is the meaning of no change? No change means whatever the present state will be is there, that will be our next state. So if your present state is 0, next state will be 0. If your present state is 1, next state will also be 1. This is known as no change. Now, next combination 0, 1 means S equal to 0, R equal to 1. This particular thing is known as reset. So it means if you apply S equal to 0, R equal to 1, in that case, if your present state is 0, your next state will be 0. If your present state is 1, still your next state will be 0. As it is reset. Reset means whatever may be the present state, next state will be by default, it will be 0. Where if you apply 0 and 1 means if you apply S equal to 0, R equal to 1. That's why this is known as reset state, or your output will be 0. Okay, that is the meaning of reset. Now the next two combination means when S equal to 1, R equal to 0. This is known as set state. Set means whatever may be the present value. Present value is means your Qn value. Whatever may be the Qn value, Qn plus 1 or next state value, by default it will be 1. So it doesn't depending on the present value of Qn. Means whatever your value of Qn may be there, it may be 0, it may be 1. However, the next output value by default it will be 1. If you apply S equal to 1, R equal to 0. That's why this is known as set. Set means output will be 1. And 1, 1, this combination is not possible in case of SR flip-flop. Why it is not possible? I discussed in my last lecture. You can go through that one. Okay. Now, using this thing, you can make the characteristic equation of SR flip-flop. How? You have to use the K-map. Okay. So use the K-map. How many variables K-map it will be there? This is a 3 variable K-map. Why? Because you have 3 input variable, that is S, R, and Qn. Okay, and from there, what you need to find out? You need to find out Qn plus 1. What will be the next state value? So this is known as characteristic equation. Okay. You have given S value input value, you have given R input value, and you have given the present input state. From there, you need to find out the equation of the next state. That is Qn plus 1 equation. You need to find out. And that particular equation is known as characteristic equation. Okay, now we'll try to find it out. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now put the value of these things in the K-map. So this 0, this 1, this 0, 0, then 1, 1. Then these things are not given. So you can consider as don't care, because these two things are not given means we can consider as don't care. Oh, so what you can do, you can make this particular word, or let me use different color. You can make this particular word and you can make this pair. Okay, so from the quad, what we'll get? That is nothing but we'll get S. And from the pair, what we'll get? From this pair, what we'll get? What expression we'll get? We'll get here R bar Qn. Okay, so this particular equation means Qn plus 1 equal to S plus R bar Qn. This is known as characteristic equation of SR flip-flop. Okay. And what is truth table? Where your inputs are given with the present state value, you need to identify the next state value. This is known as truth table. Okay. Now, what is excitation table? Excitation table is your present state and next state is given to you. From there, you need to identify the value of S and R or the input values. This particular table is known as excitation table. What I told, you have given the values of present state and next state. Okay, means you have given Qn and Qn plus 1. From there, you need to identify or find out the value of input S and R. Okay, this particular table is known as excitation table. Okay, so what are the things are available to us? That is Qn and Qn plus 1. As you have two variable, how many combinations are possible? 4 combinations: 0, 0, 0, 1, 1, 0, 1, 1. Now, how to find out the value of SNR for each of the combination? So you can easily find out the value of SNR, means excitation table value. You can easily find out from analyzing the truth table. How? For example, first consider this combination. When Qn equal to 0, Qn plus 1 is equal to 0. What should be the value of SNR? That we'll find out. Now how? So see, if you see the truth table, how many times you got this thing Qn equal to 0, Qn plus 1 is also equal to 0. How many times? 2 times. See this particular combination and this particular combination. So in these two cases, Qn is also 0, Qn plus 1 is also 0. Now in these two cases, you see what are the values of S and R in these two cases. You see S is 0, here S is 0. And in the second case, R equal to 0 and here R equal to 1. So what does it mean? In both the cases, when you have Qn equal to 0, Qn plus 1 equal to 0, your S value is remaining fixed. Okay, that is 0. Whereas R value, in one of the condition it is 0, in other condition it is 1. So it means that it doesn't depending on the value of R. So R is don't care, whereas S is remaining fixed on 0. Okay. So similar procedure you need to follow for each of the combination. Now, let's check the second one, 0, 1. So you check how many times 0, 1 is coming in this truth table. 0, 1 here, 1 time. Okay. Now see in this condition, what was the value of S? What was the value of R? Okay. S equal to 1, R equal to 0. Now see the next combination, that is Qn equal to 1, Qn plus 1 equal to 0. So how many times it came in the truth table? 1, 0, 1, 0, how many times? Here 1 time. And only 1 time it came. Okay. So at that time, What was the value of S? S equal to 0, R equal to 1. So S equal to 0, R equal to 1. Now check the next case. This 1 1 case. Now in 1 1 case, you see how many times it came? Here one time, here one time, 2 times it came. Now see, here it was 0 0 and here it was 1 0. So what does it mean? It means that R is remaining fixed at 0. However, as sometime it is 0, sometime it is 1. So what does it mean? As value is getting changed. So as you can write don't care, and R you need to fix at 0 because in both the cases you got R equal to 0. Okay. Here also you got R equal to 0. Here also you got R equal to 0. However, in case of S, here you got S equal to 0. Here you got S equal to 1. It means that it is not depending on S. So S is don't care and R is 0. Okay. This is the excitation table. And this is the rule you need to follow to find out the excitation table for each of the flip-flop. Okay. Thank you.